Hello dear students, welcome to Pen and Paper Chemistry on YouTube. We are continuing with our learning on phenols, and this is the flow chart that I had shared on the YouTube channel earlier as well for you to draw. Now let us see how we can use this flow chart, and I'm going to take up the first part of this flow chart where we've taken the preparation of phenols. So this was the first part. How do we use this flow chart? What I'm going to do is, these are the various methods, these are the various compounds from which phenol can be prepared. So as you read this flow chart, benzene is converted into benzene sulfonic acid, which is further converted into the sodium salt. The sodium salt changes to the sodium phenoxide, which on hydrolysis in an acidic medium gives us a phenol. Chlorobenzene is fused with NaOH. Sodium phenoxide so formed is hydrolyzed in an acidic medium to give us phenol. Aniline converted to phenol by, yes, of course, the diazonium compound, which we've done under the diazonium salts. This is a reaction which you would be familiar with from the preparation of alkanes, but we shall cover this as well. The last method is the manufacture of phenols, and this is done by using cumene or isopropyl benzene. Or can you give me the IUPAC name of this compound? Try it. Yes, it will be. Go ahead. Yes, correct. Because here our benzene has greater number of carbon atoms and there are no functional groups over here. This becomes my primary or the parent hydrocarbon, which is named as benzene. So you can name it either as 2-methyl ethyl benzene or, as has been written over here, isopropyl benzene. This is oxidized using air under basic conditions to give us cumene hydroperoxide, which on hydrolysis gives us phenol. Now, do you think you can write the reactions on your own? If yes, then pause the video, try writing the reactions from this flow chart, and then tally with what I am going to write in the next set. Are you ready with your pen and paper? Yes, your chemistry notebook which you have compiled in order to keep notes for offline reference. Now the strategy that I have employed over here is, I'm going to keep the flow chart in front of me just like I would expect you to do. And I'm going to write the reactions in my notebook. So I've kept the two parallelly, just as I said I would expect you to do, so that you can use this chart to the maximum. So let's take up the first preparation that we've got to do, and that is from benzene. Go ahead. So we've got benzene. It is treated with oleum. What is oleum? Oleum is nothing but concentrated H2SO4, which has been enriched with sulfur trioxide. So basically, it is pyrosulfuric acid, H2S2O7. Now benzene, because it is more electrophilic in nature because of the presence of SO3, what we will get over here is the first compound in this, and that is benzene sulfonic acid. So SO3H. I'll get the first compound, benzene sulfonic acid. Also, I would encourage you all to write the names of the compounds as well, because I have noticed that a lot of students, they don't know the name. So even though they know the reaction, they don't know the name of the compound, and then they are unable to relate to the question. So for example, the above question can also be asked as, how do you convert benzene sulfonic acid to phenol? How are you going to do that? So if you don't know the name of the compound, if you are not comfortable with the name of the compound, you may end up, no marks. And we are not doing all that study for nothing, right? Next step here is you treat it with sodium hydroxide. That means we fuse it with sodium hydroxide. Notice the temperature conditions, 573 to 623 Kelvin. You can also write it as 300 degrees Celsius to how many degrees Celsius? How do you convert Kelvin to degrees Celsius? Yes, of course, you take away 273. What do you get? Yes, 300 to 350 degrees Celsius. Am I right in my calculation? Can you let me know? Okay. So what we've got over here is you can either write the temperature in Kelvin or in degrees Celsius. Some of the curriculums, they follow temperature in Kelvin. The others prefer to write it in degrees Celsius. Both are fine. Or whichever you can learn and recall better. Now after fusing with sodium hydroxide, what will happen is the sulfonic acid will get converted into the sodium salt. But interestingly, the reaction does not stop over here. Because what we are using over here, NaOH, the sodium salt of sulfonic acid again further gets converted into sodium phenooxide. Now what is this phenooxide? If I have phenol, C6H5OH. I remove the hydrogen from it and I have this ion over here. So this would be called as phenooxide. Do you recall that in the case of ethanol, C2H5OH, when you remove the hydrogen, you get the ethoxide ion, right? Connecting the same, we have the phenooxide ion. Yes, this is where your knowledge of alcohols comes in handy. Are you writing the reactions with me? Be honest with yourself. If you are writing the reactions, then only you will be able to derive benefit from this video. Otherwise, it will be wastage of time. Yes, I should not be saying so, but yes, if you are not writing, you are wasting your time. So please go ahead, get a pen and notebook and convert the sodium phenooxide into phenol. That is by hydrolyzing or acidifying it with HCl, and this gets converted into phenol. Have we written the entire reaction? Have we got everything in place? Now if you notice over here, I have written the reaction vertically from top to the bottom like this. There is no rule like that. You can write it horizontally. I wrote it vertically simply for the ease of convenience and to correlate it with the chart that I have drawn over here. Are we done with the first method of preparation? This is first method from benzene. You can be asked this preparation from benzene sulfonic acid, or you can also use it to convert sodium phenooxide into phenol, any of it. Why have I put a line over here? Yes, please go ahead. The same conditions will apply, 573 to 623 Kelvin, and we get the sodium phenooxide. Let us now do the second method of preparation from chlorobenzene. Now I have told you the trick to use this flowchart. Everything is there in front of you. Try and write the reaction yourself. Go ahead. I've already started upon it. So as you can see, it is there. The structures part is there. Name the compound. So you have to convert chlorobenzene to phenol. Now, interesting bit over here, chlorobenzene will not react with aqueous NaOH like you observed in the case of aliphatic halides. You remember, we converted the aliphatic halides into alcohols easily by treating the aliphatic halide with aqueous sodium hydroxide, in which case we got C2H5OH. Now this is not easily done in the case of aromatic halides. No, we don't get this reaction easily. It's not so simple. We will not form C6H5OH. Can you recall why is it so? Yes, because the chlorine, because of its lone pairs, has a tendency to share its electrons with the benzene ring and acquire a partial double bond character. So it is not easy to remove the Cl and replace it by the nucleophile OH. That is why aromatic halides do not undergo nucleophilic substitution reactions easily. All this has been covered in separate set of videos on haloalkanes. There's a separate playlist on the channel. There also we have covered the properties and the reasons for the behavior of haloalkanes and haloarenes in quite detail. Use them to your advantage. Learn from those. So, if we can't do this, how do we convert a chlorobenzene to phenol? Yes, again, if you go back to what we did in the previous reaction, we fused it with sodium hydroxide. So, go ahead, fuse it with sodium hydroxide at high temperature. Yes, the conditions are extreme. You are using high temperature and fused sodium hydroxide in order to convert, and of course a high pressure as well. So this gets converted again into what is the name of this product which is formed. We wrote it just now. Yes, it is sodium phenooxide. Now, after you convert to phenooxide, what do? Yes, simply you hydrolyze it with dilute HCl and you get phenol. Simple. This is how we use the flow chart or the mind map drawn here. The third method of preparation is from aniline. Now, you are going to help me write this reaction. So you have to recall what we did under diazonium salts. Yes. So think about it. If you can recall, how do you convert aniline into benzene diazonium chloride? You remember this reaction? N positive, Cl negative, benzene diazonium chloride. Those who are, feeling unfamiliar with this topic, please go ahead with diazonium salts video and you will never regret it. You'll be really enjoying the topic of organic chemistry. So go ahead, write the next step. First of all, how am I going to convert aniline into benzene diazonium chloride? And okay, you're going to convert it. Yes, we can all see it from the flow chart. So what I need to do is to get rid of that flow chart. There it goes. I have hidden it. Now that benzene diazonium chloride is being prepared from aniline by treating it with NaNO2 and concentrated HCl. What is the most important condition for this reaction? Yes, it has to be at ice cold temperature, 0 to 5 degrees Celsius. Third question, what is this reaction known as? Absolutely right, this is known as diazotization. Now, once we've converted it into benzene diazonium chloride, it is very easy to convert it into phenol. We will again hydrolyze it, right, in the presence of a dilute acid, in which case nitrogen and HCl will be released and we will have phenol as our product. I will again insist, please write these reactions with me. I wish we could be online and I could be guiding you step by step. But whatever resources we have at hand, please make full use of that. Unless you write these reactions, there is no point in watching this video, and you will again be back to square one when the video ends. So request to you, take a pen, notebook, write these reactions with me. The third method of preparation involves the treatment of sodium salicylate with soda lime. Now this reaction, I'm going to break it into smaller bits for you to correlate it with some new knowledge and some knowledge that you already have. C6H5COOH, what is this compound? Yes, it's benzoic acid according to the IUPAC system as well. Now, next thing is, in this benzoic acid, I'm going to introduce an OH group at the second position, position number 2 with respect to the COOH group. So, 1, 2, 3, 4, 5 and 6. Hence, this compound would be named as, yes, my OH will now become the prefix, whereas COOH is the principal functional group. Hence, this compound still is named as a benzoic acid. And at the second position, we've got an OH group, hence 2-hydroxybenzoic acid. As you can see, the common name of this compound is salicylic acid, right? So we've done one part of this big name that we've got, that is sodium salt of salicylic acid. So next thing we have to do is, next step is to convert it into a sodium salt. So sodium salt means the hydrogen of the acidic group gets replaced by sodium. Hence the name of this compound now would be sodium salt of 2-hydroxybenzoic acid, or in short, sodium salicylate. Yes, the same as the sodium salt of salicylic acid. So one aspect of it taken care of. That means, supposing you see such a big name from sodium salt of salicylic acid. When I was a student, I would get nervous looking at this big name. What is salicylic acid? It was so confusing for me to recall. So it's 2-hydroxybenzoic acid. Put it in your memory bank, because we are going to need it again when we do the properties of phenol. You notice there's the OH hiding over here. So that means it's got something to do with the behavior of phenols. Anyway, more of that later on when we do the properties. Now, how am I going to prepare phenol from this? For this, I'm going to help you with the knowledge that you have already. If you recall, the first reaction that we make the students write when we start teaching them alkanes involves the preparation of alkanes by treating sodium salt of ethanoic acid. That's the first compound that we take up. So this is sodium ethanoate, right, from ethanoic acid. This is heated with sodium hydroxide and calcium oxide mixture. What is the name of this mixture? Yes, from sodium hydroxide we get soda, and CaO is also known as quicklime. So we've got soda lime mixture. This helps us to get rid of the COONA group by forming, what is the product formed over here? Look at the beautiful box that we have formed. It will help us to write the reaction more easily. So I get over here an alkane, and that is methane, right? Originally, this CH3COONA, as you have seen in the previous reactions, is formed from ethanoic acid. So by carrying out this reaction, I have managed to get rid of the COOH group. What is this COOH group? C double bond O and OH group together. So this is an alcoholic group, or more appropriately a hydroxyl group, right? HYDROXYL, hydroxyl group. And what is C double bond O? Yes, it's a carbonyl group. Remember when we introduced the names of the compounds? Now put the two groups together on the carbon. So C double bond OOH. How are we going to name this compound? Carboxyl. We've combined two parts, hence we name this group as the carboxyl group. What did we do in the above reaction? We helped the compound to get rid of the carboxyl group, getting rid of that compound. So removal is D. Being what? Carboxy group, right? So this reaction is known as decarboxylation reaction. So you are carrying out decarboxylation of the sodium salt of the corresponding acid to give us the alkane. Notice the beauty of this reaction. You started with a compound which has 1 and 2 carbon atoms, but you ended up with an alkane with only 1 carbon atom. We've covered these reactions under the playlist Alkanes, Preparations and Properties. So if you feel interested and you want to refresh your knowledge based on that, please go ahead, go through those videos, write down the reactions, refresh your knowledge. I hope you've written all of this down, because now we are going to use this knowledge in order to prepare, yes, our phenol. Go ahead, based on what you've learned so far, give it a try. See if you can get rid of the COONA group over here by following this reaction. So did you write this reaction? Yes. Look at the way that I've written the compound. It is the same compound that we took above. Only thing is, for ease of convenience, I have written the COONA here. They still are present at position number 1 and 2. 1, 2 with respect to each other. Let's draw the box, and we will have Na2CO3. And what are we left with? Yes, again, decarboxylation of sodium salicylate gives us phenol. And how do we bring about that decarboxylation? By using a mixture which is known as soda lime and heating this mixture. Isn't this interesting? Break it down step by step. Now, when you do this reaction for the first time, you must be wondering, oh, this reaction is so long. How am I going to do it? No. But in the process, you have added so many things to your knowledge which will help you to simplify things. Make things easy to understand. And when things are easy to understand, we definitely want to do more. We are now going to talk about the manufacture of phenol from cumene or isopropyl benzene. So what have we been doing all this while if this is manufacture? We've been talking about preparation. So what is the difference between preparation and manufacture? Yes, I know you know it very well. Preparation we do on a small scale. Manufacture means we are talking about the industrial level, and in the case of manufacture, we ensure that we are able to prepare it more easily and using cheaper raw materials, but getting high produce, more profitability, right? Okay. And let's see our chart here. What does it tell you about the manufacture? Yes, it's a simple two-step process. You oxidize cumene using oxygen from the air. Under basic conditions, cumene hydroperoxide. What's this peroxide? And then you acidify or hydrolyze under acidic conditions and you get the product. So let's get going and writing the reaction. Go ahead, give it a try yourself. So we have cumene plus oxygen under basic conditions, hydroperoxide. So what is this peroxide? Peroxide means the linkage O single bond O. And each of the remaining valency of oxygen is still available for bond formation. So we have the benzene ring and we've got cumene, but there is the peroxide linkage. So CH3, CH3. So basically what is happening over here, the CH bond over here is getting oxidized to a peroxide linkage, OOH. Right? And this gives us the compound cumene hydroperoxide. This is using oxygen of the air, so definitely it is a cheaper method. But where do we get cumene from? Can you please find out for me and add it to your notes? Also share the knowledge with me in the comment section. Thank you so much for being my teachers. Okay. Cumene hydroperoxide. Now hydrolysis under acidic conditions, so we can use H2SO4 over here, and let us find an easy way to form the product. So we have over here acetone, CH3, C double bond O, CH3 is released as a byproduct. Interesting, right? So you are getting a side product which is again useful, right? Propan 2-one or acetone. What is acetone used for? Find it out for me so that we can use this knowledge further when we do the aldehydes and the ketones. And we have phenol over here. Just for one clarification, this is not the mechanism. This is just an easy way to remember, just trying to make it easy to understand. This is not the mechanism. The curriculum that I'm trying to cover on the channels does not require mechanism for each and every reaction. So we are keeping our reactions limited to the formation of the intermediates and the final products. So this brings us to the end of the preparatory methods of phenol. In the next video, we shall be talking about the properties of phenol, and a humble request. If by the end of this lesson you are feeling relaxed and happy with the knowledge that you have gained, request you to share this knowledge further with your friends, classmates, or whosoever you feel may need this knowledge or may need help in understanding this topic. Stay safe, stay healthy and happy till we meet in the next video.